The bioelectrical impedance device measures the frequencies to receive impedance values, which can be used to calculate the amounts of body fat, lean muscle mass, and water in the body. Impedance is the measure of how current is slowed or stopped as it passes through a material. Impedance has two components. Resistance is the measure of the amount of the electrical currents a substance will stop. For example, adipose tissue is about 80% of fat. Fat is an excellent resistor to current. The path of least resistance would be any body component high in water content, including blood, fluid outside the cells, and muscles. The other component of impedance is reactance and is the measure of the material's ability to slow a current. For example, cell membrane can store a charge for a short period of time. The cell membrane for this reason can act as capacitor. A low frequency current of 5 kHz is stopped by cell membranes. At this point, the membranes are the resistors and no current is passed through them. So at low frequencies, any current in contact with the body is passing through extracellular fluids only. This allows the measurements of only extracellular water in the body. Current with the frequency higher than 50 kHz is able to pass through cell membranes. This allows the measurement of impedance of substances inside the cells as well as outside the cells. Therefore, measures total body water. In other words, since the force is stronger, there will be lesser resistance to higher frequencies. However, in certain cases, this is not true where the impedance doesn't drop as the frequency increases. This can occur because of environmental condition or any medical complications such as edema. This can actually cause a fluctuation in the impedance values. Impedance lowers as the frequency of the current increases. Impedance in the trunk is between 10 to 40 ohms. The difference between the left and the right shouldn't be greater than 30 ohms. Can you identify the problem in these values? Check the impedance of the trunk from 1 kHz until 50 kHz. It seems like there is nothing with it. However, at 250 kHz, the impedance value has increased from 34.0 to 46.2. We call this symptom as a reverse in the impedance. Not only in the trunk, but there are also cases where this can happen in all different parts of the body. However, some exceptional cases exist. When you see this trunk impedance, some values are higher than 40 ohm. But this is not wrong. This result is from a person who is very underweight. You can also find the impedance of her arms and legs are very high since she doesn't have that much muscle. This is also an exceptional case. You can see the trunk impedance is lower than 10 ohms. This data is from a very muscular person. He has 68.7 kg of muscle mass and he weighs around 128.4 kgs. Hemodialysis patients have more water because they have edema, so their impedance values show as if they are muscular. In this case, there is a significant difference between the right and the left arm. This person is dialyzed from the left arm. Dialyzed arm is more swollen because dialysis affects the blood vessel status and the blood flow velocity, so it affects the impedance as well. Difference will also be seen if the leg or hand is amputated.